Good morning, everyone. Thank you for coming, especially at this hour in the morning. And given the topic at hand, I am very impressed by the turnout. My name is Victor, and I will be spending an hour this morning talking about a very sexy subject like COM objects. And back in July, this happened. My friend Simon tweeted this, and I immediately identified with the problem. But I said I'm going to roll with it. And my daughter keeps still telling me that I do look like Gru. And just in case you're disoriented, this is the roadmap for Victor's Ciura for the week. You are in the third talk. Hope you're in the right one, and you won't regret it. And let's move on with it. This is part 1 of N for this topic that I'm trying to tackle. It's an ambitious endeavor, given the interest in the community around this topic. And I'm hoping to get a lot of feedback, especially at places like this, with such a diverse pool of programmers, with such a diverse background experience in actually using and deploying applications on top of COM components. And depending on how well it goes and the feedback I receive, I plan to refine and improve this and take it even further. So I do really need your help and your feedback and ideas, and let's see how it goes. We even have some chairs here left over from a different panel, so we can do an impromptu COM panel if you like. So audience participation is encouraged, and feel free to say whatever it's on your mind. Hope it's COM related though. So why COM? Why are we talking about this? Have we really exhausted all the cool template topics that we can cover at CppCon? Well, for me at least, COM has been an important part of my professional career. And this is mainly because of the constraints of the application I've been working on. I've been working on this application, Advanced Installer, for over 13 years now. And Advanced Installer, I just need to give you a little bit of a background so that you can better relate to my COM story. Advanced Installer is an IDE and a tool chain that helps software developers to package and deploy their applications on Windows. And at the same time, it helps IT pros repackage and provision operating systems and deploy line of business apps in enterprises at scale. So as you might imagine, Advanced Installer is a very wide, it's an umbrella project, is a very wide application with very different components underneath. And given the task at hand in provisioning the operating system and deploying various kinds of applications, you can imagine it has a very wide API surface area, and it actually interacts with many components from the Windows subsystem, be they older or newer features of the operating system. So basically, what we're trying is to help clients migrate their Win32 applications to the modern application model like MSIX, and maybe some of them will bring their applications in the Windows Store or Windows Store for Business. So as you might imagine, this is a big endeavor. We interact with so many components in the operating system, and as we all know and love Windows, you know that it's all built on COM components. And just before we get started, I suspect I know the answer, but I want to get a feel for the room. So how many of you have been doing COM programming in the last 20 years? OK, this is the right crowd. Again, I'm guessing, but how many of you are still doing this? Since you're here, I'm guessing it's relevant to you at least, if not anecdotal. So let's dive into it. Another important takeaway I'm trying to push with this talk, and I want to encourage a discussion around this, is that even if COM is not something of interest to you right now, or maybe it was in the past, there are important lessons to be learned about good API design, and examining COM as such an impactful infrastructure in the operating system, and as a library that has been around for 25 years now, it's very telling to examine how well some of the design choices stood the test of time, and to really see the seams in the grand design of the framework, and see which parts have played well and have aged well, and which parts really gave us so much friction along these years, and what can we learn from it? What does the modern operating system has to offer in this regard? Have we learned something over these years? Is it easier now to interact with the operating system through its COM components or not? Are we in the same mess that we've been years ago? So I'm hoping to discover this together with you. So like any good COM programmer, we have to initialize. And if you think about co-initialize X, it basically initializes the COM library on the calling thread. Very important detail nowadays. And it sets the thread concurrency model to the one requested, nowadays multi-threaded model. It creates a new apartment for the thread if that's what you need. And you really need to initialize COM on each thread that it actually needs to invoke a COM-related function. Otherwise, it won't work. So this aspect is really important. And ideally, you would want to initialize COM only once per thread, at least once, I guess. So multiple calls to co-initialize X on the same thread are allowed, but subsequent calls issue an S-false H result. And this is relevant because COM error handling is cumbersome, to say the least. And you need to be careful in how you manage expectations and check the success of the different API calls. And in the case of co-initialize, you want to be a good citizen and uninitialize the COM on the calling thread when you're done using COM functionality. And if you're not properly matching those up and not doing proper error checking to see if you're the one that actually initialized COM on that thread, you might end up uninitializing COM on that thread and somebody else in some other part of the functionality really needs it. So you can really shoot yourself in the foot by trying to be a good citizen. So you need to be graceful in uninitializing COM and do it exactly when it needs to be done. So do or not do, there is no try. By the way, any Trekkies in the room? Yeah, some of this material may be unpleasant to you. OK, so how do we fix COM initialize X? Well, RAII is something that we're accustomed to nowadays. So we can build a simple helper like this one, where we can make sure that we acquire a COM dependency and release that dependencies when we're done with it. And this is where the proper error checking comes into play. As I said earlier, we need to remember if we were the ones that actually were the first to initialize COM on the calling thread. So that's why we need to save that mclose Boolean state to make sure that we're the ones that need to uninitialize it on this thread. So if you're doing this, you can use it locally. For example, you have a function scope. You have some function requiring COM functionality and use some API. You can initialize it locally, and when it's done with it, with the current function context, you're done, uninitialized, it's OK. Or you can use it at a class scope. For example, if you have a more complex object that has several methods requiring COM access, you can hold on to that dependency as long as you're done and your object is basically tied as a dependency to the COM. itself. So that's pretty straightforward, has worked out very well for us. We actually use it heavily. I couldn't imagine living without such a functionality. Yeah, sure.
You showed like this era AI class.
Yeah, I can go back. Yeah.
Don't you need to handle model change error code? Because you can actually change
The threaded model.
Yes.
Yeah. We don't do it. Yeah, generally speaking, it's not a good idea. Technically, you're right. You can actually initialize COM with a different threading model. For example, you're using multi-threaded or switch to apartment threaded or something like that. Technically, you can do it, but it's never a good idea to mix those up. So we generally try to stay away from mixing these modes up. We've been burned before by accidental initialization with different threading models, and there were components that needed to talk with each other, and there are very careful rules of isolation about COM object instances in memory with regards to the apartment model. So we've been burned with this before, and we try to stay away of mixing those up.
Yeah, so I'm just wondering if you want to add some kind of check for that error code.
Maybe we should. At least an assertion would be a good idea, because we've been burned by this. And by the way, this class is a little simplified. It's not exactly it has to fit on a slide. But you're very right. This is a concern, and we've actually encountered, I think last year we've had a problem with this. We had a component that was not under our control, and it actually did a different threading model. Yeah, sure.
I thought this was correct, but I wanted to look it up before I said anything.
Yep.
Does quote the MSDN documentation. Find it. To close the COM library gracefully on a thread, each successful call to co-initialize, including any call that returns S false, must be balanced by a corresponding call to CO uninitialize. Your check, I think, is. Your mclose checks your result SOK. It should also check S false, because you're required to call CO and initialize even if it returns S false.
Yeah, you can use succeeded macro.
I'll have to look that up. Okay. I'll get back to you on that. I'll have to look it up.
That's very typical for COM. You
Yeah.
need to raise up every function.
Yeah, it's telling. It's telling. I think this is telling. But thank you for pointing out. I should really look into that.
That's correct, but I wanted to look it up before I actually said it.
Okay, okay. I have to look it up. Cannot confirm it. Okay. So COM initializer and RAII. You don't care about the thread you're on, as long as you encapsulate this dependency. If you don't care if it's already initialized or not on this thread. And most important thing, you can nest these objects as needed. You don't care at which point in the call stack you're in. And you don't need to about closing and unloading COM when you're done. That's the whole purpose. So let's talk about strings now. And I had to pick, COM is such a large topic, and it would be a mess to try to cover too many things. So one of the earliest feedback I got on this talk idea is that I need to pick something and focus on something COM related and try to analyze it throughout. And no question, I had to pick strings. For us, at least, this has been the most sensitive issue around COM. And I'm trying, at least for this part of the talk, to focus on COM strings a little bit. So what's the COM string type? B string, yeah, our friend. So for those of us who don't remember this ingenious piece of design, the B string is a string with a buffer in memory. It has a length prefix and is null terminated. Yeah, that's why we have the length. And the most interesting part is that bstring, of course, in the type system is a pointer, and it actually points to the data buffer in memory, not a length prefix. So there's always a trick of offsetting this pointer. So if you think you can do a thing like this, which I would expect to work, you can't. This compiles and links, and it's incorrect. And you would say that, well, I would never do this. It looks stupid. Yeah, you can, by accident, pass a string literal to a Comm API function that has a bstring formal parameter. So I'm honest enough to admit I've done that before. You can be easily burned by this. So what you have to do is allocate a string for this bstring, and you have to check the success state. It almost never fails, right? Why check error codes? And use the string and then free the string. So a lot of hand waving around just initializing a string. And somebody has to save our skins here. RAII for the win. Let's see what the Visual C++ compiler has offered us to mitigate this issue. We have a few RAII support classes. I know everybody loves this one. bstring t. By the way, these _t types really, really bad in terms of standard conformance. They should be reserved names. But we're going to roll with it. So bstring t, we have similar helpers for variants and for pointers, and of course for our result error handling friend. And because we're focusing on string, let's see what bstring t has to offer for us. It encapsulates nicely the bstring data type, manages resource allocation through sysalloc sysfree, what we would expect from an RAI wrapper. It uses reference counting to avoid excessive overhead. So this is actually clever, and it uses copy on write underneath. So you can freely copy these things as if they're value types. It provides various conversion constructors, like you would expect to initialize this data type. So meets the expectation. It's intuitive, handy. Very handy operators for lexicographic comparisons and concatenation. And you would use it probably something like this. Pass it around to some Comm API that requires a bstring, has an explicit method for getting that pointer to the buffer. And you can convert it to a standard string, because you do need to interoperate between your Comm-related classes and your platform-independent code. At some point, you need to do a two-way handshake in marshalling data between your model and your Comm layer. And of course, you can leverage the lexicographic compare operator if you need something like this. You can construct a bstring t from a standard string by getting its string non-terminated array, and you can compare it very easily. So very handy, nice, clean, no unexpected results here. If we examine the other helper related to this, a little more convoluted if we need to deal with pointers. We need to do some magic macro wizardry, and we can actually tag each interface of interest and construct on an ad hoc smart pointer reference by using this fancy macro. And we get an instant type, like, for example, I have here iTaskbar list PTR, which is a smart pointer. And I can use get an instance of this class and use it as if it's a regular pointer. So little weird using the macros, but we're used to that. So next bit of history. Who's been using ATL for the past years? Yeah, ATL fans in the house. So just a quick orientation or a history lesson. This would be a simple ATL structure. The core object in ATL is CCOM object, which is a template class. And I'm not going to cover aggregate objects because it's a much more complicated topic for this discussion. But if we're talking just about a simple COM object, a COM object inherits its template parameter. And this would be a very, very contrived and simple example of actually creating an instance of this circle object and invoking just one method of interest on it, set radius in this case. And this is what we would have to do. And all of this is just boilerplate. I don't care about any of this code, but I kind of have to write it. And this isn't even the whole class. I couldn't fit it on the slide. This would be the actual code I care about in being my constructor and my methods of interest. So having to write all this boilerplate code really messes your attention, and it's sometimes error prone and definitely gets in your way. By the way, do you recognize this pattern? It has a name. Yeah. CRTP, curiously recurring template pattern. So basically, it achieves a similar effect to the use of virtual functions, but without the cost of dynamic polymorphism or a vtable. And it has binding at compile time, of course. We want this for our COM objects. We don't want virtual code for each COM method. And the pattern is used extensively in ATL and WTL libraries. We actually use a lot of ATL in our application, and our whole GUI is built on top of WTL. So I know pain when I see it. But it's a very powerful construct. Building up objects this way is flexible enough, very powerful, not very friendly for the beginner. So we do have parallels and helpers in ATL for the same constructs. And we have CCOM putter and CCOM bstring. And of course, I'm going to pick on CCOM bstring because we're talking about strings. So this is the ATL wrapper for bstring type. It manages allocation again the same way because it's the same type underneath. But this one does not implement copy on write. So this object is different. And in the latest versions of ATL, it actually has move semantics, just in case you didn't know. So it provides, again, various conversion constructors that you would expect to initialize it, same convenience operators. Usage looks similar with bstring t. The difference being that CCOM bstring actually has an operator to convert it to a bstring automatically. This might be helpful or might be surprising to you, depending on if you wrote the code or not. You can initialize a standard string from CCOM bstring. Of course, if we're talking about, I didn't mention this earlier, if we're talking about COM strings, we're always talking about UTF-16. So this is the underlying assumption and how the operating system is built. So you're going to see only stdw string in the slides. So you can marshal data back and forth between your model or your application logic and the COM components. You can construct the other way around. You can construct a CCOM bstring from a standard string. You can compare them. Similar functionality with bstring t. So at this point, I would like to run an ad hoc poll. How many bstring t fans versus CCOM bstring fans? So bstring t. Bstring t. Oh, not a love. No love for bstring t. CCOM bstring, ATL. ATL for the win. OK. Just a personal curiosity.
Actually, a quick note
Yeah.
It will be interesting for people. If there is a piece of cross-platform code, I understand it's like Windows related, but
Yeah.
sometimes you have to integrate with cross-platform library.
Of course.
That will be using Tlc String. I remember the problem is that W string will be 4 bytes on non-Windows platforms, while it will be UTF-16 on Windows. So basically, if you do have to write cross-platform code, you also will have to do either if-that based conversions from W string from Windows to W string on non-Windows.
I'm just gonna summarize what you just said to be on the recording and other people to follow. So a very good observation. If you're dealing with any cross-platform development and you need to isolate some platform abstraction layer that's COM dependent, and you do need to do this marshalling between standard string and COM string, you do need to be careful about the string representations on other platforms. And it's indeed a very good observation. And I remember a talk a few years back. Some people on the Office team did a presentation that I thought it was fantastic. You should look it up on YouTube or Channel 9 or something. I don't remember the title, but the whole talk was around their experience in actually porting the Office to iOS and the challenges they faced around data type lengths and endianness and character lengths on different platforms. So that talk goes into many details around data representation in memory and depthing and this constructing a proper platform abstraction layer. And it's actually an actual real case study on from the Office team that did all this work, and it wasn't easy. You should definitely, if you're interested in stuff like that, you should definitely look it up. I'm sorry I don't remember the title, but it was an excellent talk. Yeah.
Just a quick comment.
Yeah.
Maybe 2 comments.
Sure.
Because I kind of raised my hand for both Beaster and ComBeaster. I use both of them.
Myself included.
One advantage that I've found with CComBeaster is it does overload the address of operators. So if you're passing it to a COM API that takes a ret val,
Yeah.
you can use ComBeaster to capture the ret val where you can't do that cleanly with the _beaster construct. The other note that I would have
Excellent.
is in your construct where you're constructing W string by passing the direct reference to the beaster, the line, I would be very careful about doing that in production code. The reason being, some languages return non-null terminated beasters through COM interfaces, which is allowed, and the wrapper classes, while providing convenient overloads for the effective null terminated strings in C++, don't check that necessarily. And if you use that construct with a beaster that came out of Visual Basic, for example, it will likely crash.
Yeah. Very good 2 observations, and I'm going to repeat them to be on record. The first one is that with regards to the poll I made earlier, bstring T versus ATL CCOM beaster, we actually use both, like you said. Different components, different authors. What are you going to do? That's life. And the preference here and the observation was made that if you have an API that actually returns a string as an output parameter, the CCOM beaster having a get address of function can actually be used to capture an output parameter. Did I convey that correctly? Sure. Okay. And it has a clear advantage here over bstring T. The other observation, which is more subtle, is regarding embedded nulls, or if the string isn't null terminated. COM, of course, has projections in different languages, and if you're talking about COM, the whole idea is about interop and being language agnostic around a common API. And if you happen to get a hold of a string reference that is not null terminated, actually constructing a standard string this way, like line 3 here, is potentially dangerous. So you better watch out for the string length because it's not null terminated. Did I convey this correctly?
Yeah, I was just going to add to that. there's a way to construct the std strings passing the pointer and the length.
And the length, exactly.
And you can actually macroize that, which is what we've done in our code to conversion.
I would rather be explicit than put a macro there, but the observation is valid.
ATL has conversion macros like CW to CT. So
Yeah.
C string
Yeah,
to B string, B string to C string.
yeah, I'm not a fan of those, but we do have them in the code base. So, question here?
Yeah, so with the std W string 32-bit problem, there are types in the standard for like UCAR 16T and so on.
Yeah,
so
yeah.
You can lock yourself in.
Yeah, and the basic string class is templatized. So W string is just a template instance for WCAR-T. So you can actually use the other chart types in the standard. Good observation there. Good observation. So again, this is a contrived example, and it actually assumes a null-terminated string. So yeah, very good observations. I'm definitely in the right room. No, seriously, actual audience participation in this talk highly improves the content. So there's a bigger fish here. There's always a bigger fish here. And this would be Tlc String, one of my favorites. So again, this is a templatized class, has support for char, WCAR-T, and string traits. It manages allocation, deallocation, of course. Uses reference counting to avoid excessive copy or overhead. Again, this is a copy on write implementation. Very handy. I see so many people trying to avoid C-string copies and passing references around, and I always find that a futile effort. And it actually has a string ref internal representation, and it correctly checks that it actually needs to duplicate that string when modifying it. Has a lot more methods and operations than bstring t or ccom bstring. Has all the conversion constructors you would expect, including variant, which is nice. All the operators that you would expect for convenience. Lots of algorithms and utilities, as opposed to the other ones that are bare wrappers around the data type. This one actually has string algorithms like find off, formatting strings, changing the case, the uppercase, prefix, suffix, substrings find, reverse find, tokenize, what have you. All the goodies you would expect from one string class. So definitely my favorite. In terms of simple usage, again, you can imagine calling some API that requires a bstring, and you have to be explicit about requesting an all-a bstring from the C string. And the other way around, if you're trying to construct, this is the most frequent offender in our code base, actually, data marshalling buffers between standard string and C string, I think is the most frequent operation we do in our application, because we have all the application logic and the model of the application built on top of standard string, and each time we need to interact with the GUI. The GUI again is built on top of ATL and WTL, so everywhere is C string, and interacting with COM, and we copy things around. Yeah.
You know that leaks, right?
Sorry, the line 2.
Yeah.
Line 2. Yeah. No, it's just I'm just trying to show the conversion function. Actually, I've never used the alloc C string function from C string. I never needed to. So. But the third line is the thing that we have. I think that's the most. If I do a search, maybe C string get string is the most frequently used function in our code base. So that's unfortunate.
But can we clarify what is the leak?
Yeah, the alloc C string method actually allocates a bstring copy of the underlying C string buffer.
Well, and specifically, bstrs are allocated in global memory in COM. There's a
Exactly.
And they have to be freed by CO free, I believe.
Yeah.
And Tlc String calls CO malloc and returns the raw vstir pointer. So
Exactly.
don't do this. Write a macro like cstir to vstir that returns one of the
Exactly.
CO com object or vstir t.
Yeah.
Then you can call this directly just using your macro around the str.
It's the same problem you have with sysalloc string and sysfree string. You have to manage those manually. So I would never advise using alloc sysstring. There are some convenience macros like he mentioned, and it's rare that you actually need to do this back and forth, but in case you do, you need to be aware that you get new bstring instances. That's why I put the allocates comment there. And what I'm trying to deal in this slide is with the type system itself, not the memory management. So the conversions that happen. So again, and the other way around, again, this is a very frequent operation in our code base, converting from a standard string to a sysstring to give it to some GUI function or working with some COM component there. So these are a pest for us, and they always give me headaches, and I'm trying to get rid of those. So, but what about this modern COM I keep hearing about? Surely things have improved in the last 25 years. Enter Windows Runtime. Starting with Windows 8 and Windows 10, we have a new kid on the block. This is a new day, a new beginning. So the Windows runtimes, for the ones that are still stuck on Windows 7, yeah, we still need to deploy applications there, right? Is a modern class-based object-oriented Windows API. It has rich metadata about the classes and members, the properties, has language projections for natural and familiar use in your preferred language. Okay, not Ruby, but it could be done. And how do I get access to the Windows runtime from C++? Well, let's start with the beginning. We have world. Yeah, that's how we started, right? Before there were any real projections, we have the Windows Runtime C++ template library. That's a mouthful. It enables you to more easily implement and consume COM components. It's a very thin abstraction of over the API. It's template-based, of course. It gives the ability to control the underlying code. It's very low level, so it's not always pretty. Error handling is still hresult based because it doesn't abstract away anything on this front. Its design is heavily inspired by ATL, so one huge benefit of this approach is that you can actually mix in old COM code with new COM code. And this is the main reason that the Windows Runtime effort was bootstrapped this way. I always consider this, the world implementation as a transitional period so that you can bootstrap and start adopting newer APIs in your existing old application and to have a seamless interaction there. And of course, it was easier for them to implement this until we got an actual language projection in the form of C++CX later. So it actually uses standard C++, and it's template-based, like I said. It uses smart pointers, RAII over the place. It actually helps with activation. So it was a clear improvement over the pure ATL-based approach. Rather verbose, though. And of course, it allowed us to add support for UWP applications and leverage new APIs there. Immediately after that, I'm doing I think you got the gist of it. I'm doing a history pass here. So quickly, we got a language projection that it was C++CX, if anybody remembers that pain with the hat. It uses a non-standard C++ language extension. The Visual C++ compiler was enhanced to support these language extensions. The syntax is terse, clean, much less boilerplate. All the things, the compiler does all the messy work behind the scenes. We just write simple code. But there's a learning curve. This being a non-standard language extension, you need to get accustomed to the hats and how it works and know the reference counting that happens behind it and understand it a little bit. So there's a learning curve. Definitely high-level abstraction here. Something nice about it, I'm a big fan of exceptions, I'll admit it. Not the right conference to do it, but I'll admit it. It actually encapsulates H results as exceptions, automates various housekeeping tasks of initialization, but it's discontinued. So let's start to see how it would look like. Init would be some includes and namespaces, nothing special there. RAII for the win, again. This time, this helper is actually provided for us. It's not something I implemented. So very similar to what we had earlier. Row initialize helper. Simple usage would require to get an activation factory, to get an instance of, for example, Ciura runtime class interface. So looks like ATL, a little bit different. Still very verbose, not my cup of tea. But what's the Windows runtime string type? Again, I'm going back to this theme of strings. So Windows runtime string type. Hint, it's not bster. Sorry? H-string. H-string, yeah. It's always an improved model. It represents an immutable string. Careful here, an immutable string in the Windows runtime. It's basically a handle. And in order to get a hold of these H strings, you have to use functions like this. And man, they're ugly. That's a very sad API surface. But that's what we have to deal with. And we have class representation. For example, a very simple odd thing. You cannot initialize it by construction with a string literal. You have to actually call the set method. I thought that was sad. So a very simple example of initialization there. Platform string is the language projection for C++ CX. So if you were using C++ CX, that would be the language projection for it. This time around with the C++ CX projection, it looks nice. I can see a clean initialization as opposed to this garbage. Has the expected operators, checking for equality, concatenating stuff. It's good. But you cannot stop change, and people don't like non-standard language extensions, and I consider the evolution step in the right direction here. And going back to standard C++ is what you want to strive for. And you don't have to rely on a specific compiler for some language extension. So C++ WinRT comes into play. It's an ISO standard C++ 17 language projection for the Windows runtime. It's a header-only library. It has C++ class wrappers for the WinRT APIs. You can author and consume Windows Runtime APIs with it, and officially supersedes the WRL and C++ CX. So definitely, this is the present. How many of you are using C++ WinRT? Wow, that's sad. I guess we haven't got rid of Windows 7 yet. That's clear. So this is an open source project. It was a long time on GitHub. It actually moved to the Windows SDK a few months back. And I think this is the best documentation to start with if you're trying to learn about it. And we have to thank that man for this. And let's give him a round of applause, please. Kenny did a very big effort in actually striving for bringing uniformity and using a standard C++ and surfacing all the richness of the APIs in C++ WinRT. And I'm so happy that it's finally part of the Windows SDK and actually feels like it's a first-class citizen, and using C++ to program a Windows runtime is actually legit now. I feel welcomed in the platform, finally. So I highly recommend that you see this talk, if you haven't seen it already, from last year's CppCon. It's a talk all about WinRT. And from this year, a more recent version of using C++ WinRT to author UWP applications from the build conference in spring. So how do I get it? Well, fortunately, it does come with Visual Studio 2017. You just have to select the C++ workload and you're up and running. It's as simple as that. I would also add, I would like to see, I understand the reason of rolling out extensions in Visual Studio. It actually gives you the flexibility of updating on a different cycle and pushing things a little off pace or off band than the regular product updates. But I would like to see more support right in the box. And this extension helps you. I highly recommend that you check it out. It actually helps with the bug visualization for C++ WinRT projects and provides you with project templates to get started with building C++ WinRT applications, and has support for MS build and generating projection headers and components. So this is a separate extension you can install. So let's start with the Windows Runtime. Again, much more simple this time around. We have to actually give the linker some instructions there, include either WinRT base or foundation, which automatically includes base, depending on your need. And you can just basically start going. Notice there, it does require C++ 17. So I'm there. How many of you are able to leverage C++ 17 in your work? I say a fifth of you. So it actually performs better and produces smaller binaries than any other language projection. It outperforms handwritten code using the API interfaces directly, like Word did. The underlying abstraction uses modern C++ idioms that the Visual C++ compiler is designed to optimize for, like magic statics, empty base classes, string length, elisions, and so forth. So leveraging non-standard stuff actually helps, because the optimizer doesn't look for improving non-standard extensions. What's the CPP WinRT string type? I'm getting to my theme of strings again. So what's the string type? Anyone? No, but very close. It's WinRT H string. Yes, you guessed it. So yeah, question.
We use IDL, interface definition language,
Yeah.
quite a bit for the interfaces. Can we have H string going into the IDL?
Maybe Kenny can help there. I don't know. Regarding ADL, the question was if he uses ADL to define its interface. IDL, sorry.
From IDL, interface definition language, and whenever there is a need for a string, we pass beast or there.
Yeah, so if you're authoring a Windows Runtime interface, it has to use an H string, not a B string. So it's classic COM interface. It could be a roll string, it could be a B string, it could be whatever you like. In the Windows Runtime type system, it has to be an H string. So that's the only string type that is permitted by IDL, by the metadata that it produces, and by the runtime.
That means the old IDL and new IDL can't work together. Is that correct?
Well, they can work together in the sense that you can have a COM object that implements both kinds of interfaces, the WinRT interface and the COM interface, but the WinRT type system only supports one string type. And IDL is just a way for you to describe the interface that then gets encoded in a binary metadata format, and that format only supports H strings as a single string type.
If I can summarize that for the camera. So maybe I wasn't very clear, but the Windows Runtime is not built on top of B string. Like Kenny said, it's built on top of H string, which is a different representation. So if you're defining a component, it has to be defined in terms of H string type, not B string. And I would also add that if we're talking about middle, yeah, it's a different middle version for authoring Windows Runtime. That was middle 2. And that was a very baroque and very verbose language of describing interfaces. And it was improved in middle 3, is a much more lightweight and airy mode of describing type libraries. So I've actually seen a very nice interview with Larry Osterman on Channel 9 around this, and the changes that he needed to operate on actually describing the Windows Runtime. So definitely, the Windows Runtime is focused around H string, not B string.
So, do you have any recommendations for people who are using IDEA right now? How we can move to using the H string of the WinRT?
Do you want to take over?
Yeah, I think it's best because we're almost out of time and I still have a few slides. Yeah. Okay. So WinRT H string represents an immutable string consistent with the underlying H string. You can construct it like you would expect. Has various constructors for your convenience there. Again, also the version with the length and the pointer. Has an explicit constructor with string views. A few examples, you can construct it in various ways, from a string view, from a pointer and length, all the usual suspects there. Nothing unexpected. The operator that converts it to a string view is interesting, in my opinion. And I have a whole talk on string views that happened on Monday, but you can catch it on recording. The string view is actually meant to be a glue between these string types. And my hope is that string view will solve all our interop problems at API design level and will help us bridge this gap between different string types in our type system when we're talking, for example, of standard string and WinRT H string, for example, or other string types for that matter. And you can see in this example, I can initialize a standard string from the return result of this domain method that returns an H string because of that explicit operator that converts it to a string view. And of course, I can construct a standard string from the string view. So that's a very nice way to compose things. So H string is also range. H string exposes almost the same interface as standard string, and I think you asked a little earlier, you suspected that the standard string type for the WinRT is standard string. It's not, but it's something that's almost like a standard string. So it mimics the same API, same interface, although the string is immutable, but it looks and feels familiar, and it can interoperate seamlessly. So it actually feels like you're using the standard string. You don't have to worry about it too much. And you can use range 4, you can treat it like a range, just like with standard string. Although each string, again, is UTF-16 underneath, it does play nice with, if you do need to do some data marshalling in terms of UTF-8 text, it has convenience methods to transform it to a narrow format, for example, like UTF-8, if that's needed in your case. We don't have that problem, but I guess there is scenarios for that. Mostly in terms of if you're doing cross-platform stuff. So we end up with something like this in our applications. And I love this slide. The highlighted stuff is basically just your calm pleasure. So yeah, we kind of have to deal with all of these. So it's tough. So you have to think about, okay, I'm doing my business logic, my platform independent stuff in standard string. I'm doing all my platform-dependent stuff, my GUI, my COM objects, my platform abstraction layer, whatever. I'm doing that with, let's say, X string, whatever that is, COM, whatever. And I have to do this data marshalling and interop and tie those things together so they make sense. And that's all fine until your application grows and you start to build up utilities and algorithms around strings, and then pain comes into play because you have to decide, do I implement all my string algorithms in standard string? Do I do overload sets for my X string types, whatever that is? Do I fall back to a common denominator thing and make all my algorithms in terms of pointers to characters and lengths? That's always ugly. So this is where string view hopefully is the answer. Like Billy said, is the duck type of the string types. I like that type. And it's still an ongoing journey, but we're trying to discover if string view is really the answer to all our string problems. And that's why I have this whole quest of actually trying to figure out the good practices and all the gotchas around using string view. And of course, you have the limitation of actually being able to use this if you're on C++17. There are similar classes out there for C++11, like Upsell string view, for example. But again, you might have limitations on what you can use in your code base. So definitely a lightweight string-like view over an array of characters. It basically maps this concept of pointer and length. It was designed as glue code and to reduce the overload sets for your classes. That's its main purpose. But it does not manage the lifetime of the object. Clearly, it's a projection over an immutable sequence. So it maps really well to WinRT string, which again represents an immutable object. The lifetime issue is a problem. That's the main concern. It has all the usual suspects in terms of constructors and conversion operators. Not all of them explicit, unfortunately, or fortunately, depending on how you see it. And because of that, it does come with plenty of gotchas. So my whole talk about hanging yourself for string view is around those gotchas and trying to determine best practices in properly designing APIs around string view, and where is it safe or comprehensible to use it in formal parameters rather than store it in as a data member or in containers. And we're still figuring this out. String view is a strange type. It actually deceives you in that it's actually a value type, but it fails to actually conform into being a proper regular type because of its assignment operator and how its comparison function works. So it's difficult, it's deceiving. So we're still figuring it out. And it has real potential to really help us here, especially, my hopes are especially around COM and string view. And I'm trying to figure out how I can make this work in my code base. And it's a learning process, but I'm optimistic. So Windows COM is 25 years old, and this shows in many corners. Yes, it's still relevant today more than ever because Microsoft has bet in its entire WinRT API on it. So we're going to live with it. And with the advent of C++17, using COM objects and the new WinRT APIs feels like a new experience, in my opinion. So definitely something to strive for. So the dark side of COM is the pathway to many abilities some consider to be unnatural, but I'm very optimistic and I still enjoy programming COM. So with that, thank you.